Any problems? Okay, all right, good. All right, any problems you see? What would you say your U is? Okay, what's your DU? Is that what we have? Yikes. Okay. So we're gonna have to do something a little different here, all right? Because what I have is an X, what I need is not an X, right? Okay. At the very least, constants aside, my variables have to match. Okay, like my dx, du stuff variables, those have to match up, and right now they don't. Okay, so that brings us to what we're doing today. All right, we're going to apply U substitution and evaluate our integrals, and they're going to require a little bit more out of us. Okay, we're going to have a couple of additional steps in order to rewrite our integrand. So this is what I want you to be able to do by the end of this lesson. Okay. I want you to be able to identify an appropriate substitution method for a challenging integral, okay? And adjust, simplify the expression as you're needed to so that you can take that antiderivative, okay? So kind of keep that in mind. By the end of today, that's what we want to be able to do. All right, so if you'll get your notes out, we're on page 48. This kind of scenario is what we're going to do when you have a du that just doesn't match what else is under your integrand, okay? But as we already said, we believe that our u is 5x plus 1, okay? Now, I go over here and I look at it and I can tell because I'm constantly thinking ahead in the problem as I'm working it. And I'm thinking, I know that my du is going to be 5, right? And I look at this and I'm like, that's not what I have, right? But what we can do, I'm trying to build up your integral toolbox a little bit, okay? What we're gonna do is, bear with me here, okay? I want you to rewrite this expression in terms of x. So in other words, I want you to solve for x. How would you solve for x for that equation? U minus 1 equals 5x. Okay, so what does x equal? Yep, u minus 1 over 5. Okay, so I want you to do that first, and then I want you to sub that new expression for that single x, okay? So what I mean by that is, instead of this being an x, I want you to write that as u minus 1 over 5, okay? Now, this part of it up here should be an easy rewrite, because what's underneath there? What's underneath our root? 5x plus 1. What does 5x plus 1 equal? U, okay? So here, I'm just gonna rewrite that as square root of u, okay? And then that's du. Now, we're not done because I still can't integrate that as it stands, all right? What I am gonna have to do is some algebra, okay? So that's your next step. Do some algebra, okay? It's our favorite part. Let's do some algebra, okay? If I have u to the 1/2, and I'm multiplying that, actually I'm gonna do it like this. I'm gonna pull this 1/5 out for a second and put it over here. 1/5 times u to the 1/2 times u minus 1, okay? What can we do to multiply these? Distribute, okay? All right, what's u to the 1/2 times u to the 1? What do we do when we multiply exponents? Add them. What's 1/2 plus 1? Okay. And then minus u to the 1/2. There's our algebra, okay? So, here's my rewritten expression. Do it.
Where did the 3 over 2?
1/2 plus 1. When you multiply u to the 1/2 times u to the 1, you add the exponents. Alright, so I've got that 1/5 hanging out, okay? And then I've got u to the 3 over 2 minus u to the 1/2 du, okay? And that, while you may not be excited about it, is an expression that you can integrate, okay? When we have just a single power, what do we do to the exponent when we take the antiderivative?
Multiply it by the coefficient.
That would be if we were doing the derivative. If we're doing the antiderivative, we have to do that backwards, right? So what do we do first? We do something to the exponent.
Add 1.
Add 1, okay? So I'm gonna have that 1/5, and I'm gonna have u to the, what's 3 over 2 plus 1?
5 over 2.
5 over 2. And then what do we do to the, then what do we do after that?
Divide.
Yes. Okay. The u to the 1/2 is gonna become u to the what?
3 halves.
If we have 1/2, now we're gonna have
3 halves.
3 halves. Okay. Now we just have to clean that up. All right. So I'm gonna have the 1/5 times the 2/5 square root of what? U to the 5 over 2 is gonna be what? Square root of the u to the 5th. And then minus the 1/5 times 2/3 square root of 3 cubed. What's our last thing besides adding our plus c that we need to do? What do we do to the u's? Thank you.
Ugh.
Do y'all need a second to process?
Yeah, you gotta watch through all of this homework.
I'm going to. We're fixing to work another problem. It's a lot.
Dude, this is insane.
It's a common feeling. There we go.
What did you just put on your board?
What?
It's not that bad.
I know.
I couldn't get past step 1.
Okay, well, let's. Do we understand why I couldn't work the problem as is?
Yeah, we get that.
We got that. Okay, great. I gotta start from the beginning and let's see where we're at. I know that this is one of the most difficult integral things that you'll do all year, okay? Well, at least until the BC integrals. All right.
Until BC what?
Integrals that we have to learn. It's fine. Huh?
This is ABC.
Yes. It's fine. It'll be fine. It'll be fine. McKenna, it'll be fine. I promise. It will be okay. Okay? The stuff we did on Thursday seemed hard at first, right? Today it was not as bad, right? It was a little bit not as bad, right? Okay. The stuff we're doing today is bad right now. It'll be okay. We're gonna get there. All right? Just trust in it, all right? Okay, since I know I can't do that, okay, I'm gonna rewrite that u expression, which I could tell that that's what my u is supposed to be, right? Are we all there? We can tell that that's what the U should be, all right? So I'm gonna rewrite that in terms, because I need to get rid of this X, okay? Like, I can't have that. I can tell because my DU would be 5. I can't have that. So instead, I'm gonna rewrite that X to be a U instead, all right? So I take my expression, U equals 5x plus 1, and I change it around, and now it's an X, okay? Still shaking his head like, nah. Okay, all right? So, we're gonna do the next problem one step at a time, then I'm gonna pop back up to this one and we'll look at them one piece at a time, okay? I want you to look at this one, okay? I have x squared, square root of x minus 1. What would you say your U is? X minus 1. Now, thinking ahead, my DU does not match what I have, right? Okay, is that clicking so far? I mean, I think that's the only thing so far that's clicked, but we'll get there, all right? So, instead, what I have is an x squared. What I need is just a 1, all right? So I'm gonna fix it. So I'm gonna rewrite in terms of x. Okay, so x actually equals what?
U minus 1.
Close, almost, U plus
U.
1. Because I would just move the 1 over to the left-hand side. Okay, that's the first step. I see that my DU's not gonna match, so I'm gonna try this, all right? So now then, let's look back at this one. I need to get rid of this x, so what I did was I subbed in a new expression that I wrote for x, right? So instead of this x, now I've got this expression instead. Does that make sense?
Yes.
Okay, great. Let's do that here. Okay, gonna sub in my new x, okay? This time, I have an x squared, so I'm gonna do this. U plus 1 squared. Okay? And then square root of what?
U.
Yeah. Okay? And I'm gonna clean that up a little bit. What do we do when we see binomials that are squared? FOIL. Okay? So I have u squared plus 2u plus 1 being multiplied times u to the 1/2, right?
Yes.
Make sense so far? Now I've just got to do some algebra to rewrite that expression because I don't have a good product rule for antiderivatives. I can't take an A and a B or anything like that, okay? What I can do is distribute the u to the 1/2, right? So that's what I'm gonna do. I'm gonna do some algebra.
That phrase is gonna replay in our heads.
Just do some algebra. Okay. All right. It's our favorite. I need to distribute u to the 1/2 and u squared. I'm going to multiply those together. What do I get when I multiply u squared times u to the 1/2?
U to
5
the
halves.
2.
5/2, because I'm adding the exponents, okay? Then I've got a u to the 1/2 times 2u to the 1, okay? What do I get when I add those exponents?
2u to the 3/2.
That's it. Okay, then I've just got u to the 1/2 times 1. That's easy. Got it. Okay. Now, is that an expression that we can anti-derive? Yes. Okay. It's not necessarily a fun one because it's got a whole bunch of fractions in it, but that's all right. Okay. So now you can anti-differentiate, integrate, whatever you wanna call it, okay? U to the 5/2 becomes what? 7/2 divided by 7/2. How about U to the 3/2? It becomes 5/2 divided by 5/2. How about U to the 1/2? Becomes 3/2 divided by 3/2. Okay? Now you just clean it up. So I've got 2/7 square root of U to the 7?
What?
What? Where did I lose you? Did I lose you on that?
Yeah.
Did that-
How did it? Right there. Right there.
Okay, alright, okay.
So where did any of that just come from?
Yeah.
Where did what come from?
You
The
lost me
2/7?
from the 2 all the way to the
2/7.
7.
You're multiplying by 2/7.
Keep, change, flip.
Oh.
Alright. That's U to the 7/2 divided by 7/2, right? So now it's U to the 7/2 times 2/7.
Oh, and then you just rewrote the 2
Yes.
7/2 as like an actual.
Yes.
Okay. Never mind.
Alright, what's the next coefficient gonna be? I'll make y'all do that one.
2 divided by 5
Times.
2 times the square root of U to
Yeah.
the
There we go. Alright, and the last one, what is that gonna be?
2/3 square root of
And then you plug in your U, which I don't really have a lot of room to do. I better do it though, just in case the band students wanna look at the notes online. Let's see, X minus 1. Alright, while I'm rewriting these, I want y'all to look at the next one and see if you can start to set it up. And
So
we'll.
you don't actually have to solve, you just have to plug it in. Like from there, like at the
Why am I
end.
writing sevens? Do what?
You just have to plug in the U's. at
Yeah.
the end.
Yeah. There we go. Okay? Alright, so take a look at the next one and see if you can start to set that one up and solve it. Now, I mean, go ahead and like, actually, talk with each other, talk through it, cause the best way to get to where this stuff makes more sense is to start talking through it together, okay? Alright. And then I'll come around and see if we've got questions on the setup. Just get to the part where you rewrite. Questions, or do we know where to how to get started? Is it making more sense now?
Yeah.
A little? Wait, yes, but that one should be squared. Yep, but you got it. Okay, you good? Yes, that is it. And Maureen, what do I have out back here?
Can we pull the 3 now?
You can.
Can you sure? Before I go
Very
on?
good, very good. All right, you guys, see, I told you, you've already started to get it, okay? As I'm walking around, I'm seeing that. Or, if you went ahead and decided that you wanted to pull that 3 out, you can, okay? So there you go. What's our next step?
Foil.
Foil and distribute, so go ahead and do that.
Would you,
This one's a little nicer because it doesn't have a square root in it. Alright, I'm just gonna check and see if we've correctly simplified it. Yes. Oh, you're already almost done with it. That'll work.
I always forget yours.
Oh, I pulled my 3 out, so, yes, that will work. Yes, that's correct. Now, once you take the antiderivative, you can get rid of it on the side. Oh, we already got an answer?
No.
Oh, okay. Oh, I was looking at this one down here. Yes, that's exactly what I got. Yes. Mm-hmm. All right, great job, you guys. Got this far. And if you haven't already, some of us have already finished it and started the next one. Go ahead and take that antiderivative. And then we're gonna practice a little bit, identifying some U's, DU's, and, hang on, I can't write and talk at the same time. U's, DU's, and, still can't. And rewriting. We're not gonna actually fully solve, we're just gonna practice identifying those harder pieces. Alright, let's see if we've got this. Yeah? Yes, yeah.
Did it go to you or her?
No, it goes to her.
Okay.
Yeah, she she sent that out to us and asked us to send it to y'all, and I was like, okay. But then that's not what she linked. So,
I know, I saw it, that's why, then I looked at it and I was like, oh, maybe some questions.
yeah. So, I appreciate it.
Thank you, ma'am.
Just still.
Good luck, y'all. It's been a hot minute.
Is that what y'all got?
I got to where, like, the second to last.
Okay,
Right before the answer, I got there. Now I'm just trying to figure out how I get to.
I just distributed the 3 to each one of the terms and then plugged my U back in. So, I mean, you theoretically could also say 3 times x plus 4 to the 8th over 8, you know, minus 8, you know, and like that. You could do that.
I think you're frozen.
And so, oh, whoops, sorry. You could do that, and so on. And just leave the 3 on the outside. Are we ready to take a break? I had a brain break planned, and then it really flopped second period, so I don't want to do it.
What was it?
It was a left brain, right brain thing, but everybody was able to do it, so it was like not fun. So I'm open to another brain break suggestion for today. Who's got an idea?
Roy said you had to.
Miss Peter, what if instead of taking our quizzes before class, we took them after class?
Why?
Why?
Yeah.
Like as like a, so we can like review a little bit, like any like actual like work.
Well, I don't wanna take time in class to review it. You
Well,
know?
not like review it, but like just doing this makes me see, oh, like I did something wrong.
Oh, I see what you're saying. Yeah. Yeah. I wouldn't wanna confuse the new learning with the old, which is why I've always done them at the beginning. I don't know, I'll think about it. I'm also worried because your brain's gonna be more tired after an hour and a half of doing calculus than it is at the beginning of class.
Miss Peters, the quizzes are like actually grades. I thought it was just like completion.
No, they're actual grades.
Oh.
Humble brag.
Well, he did take this class last year. Or not this last year, but he took AB last year. So he hadn't had to work real hard at it this quarter or semester. Alright. Well, let's see if we can figure out how we would rewrite some expressions, okay? So I wanna see if you can rewrite it. Don't like take the antiderivative, but see if you can figure out what the u, du, and the rewrite would be. Sometimes you may have to do that x sub n thing, other times you don't.
think I'm feeling good.
Do we have an idea yet for this one?
Chain rule in the denominator?
What do you mean chain rule?
I don't know, I look at that and I see the lnx under the.
Mm-hmm, it is, I mean, it's the integral version of chain rule, sort of. It is a U sub problem. What would your U be, do you think?
1 over x ln squared.
Just the ln of x, actually, would be your U, okay? Because your du is 1 over x, right? So then how do we rewrite that?
Just ln square root.
Close. How about u over square root of u? Yeah. Because it's ln over square root of ln. Ln is u regardless, right? It just looks funny to us. So it just becomes u over square root of u, which actually does simplify just to u to the 1/2. I mean, like. Okay. Let's look at another one. Now again, sometimes you gotta do that change of x thing that we learned today. So just.
I have no idea. It makes sense to me. Yeah, and you have to solve for those. And so I got this. Stupid. And what I'm thinking is you write it like this.
Do we have a u
Because, yes.
and a du? Go. This one's a little different.
Yeah.
I already know I'm gonna have to explain this one.
Not reassuring.
No, because.
All right.
Stop.
I'm assuming that we got something like that, right?
Yes.
Okay, okay. I want you to think about, okay, so first of all, I've got to have an x dx to equal du. Does that make sense? What I had instead was an x cubed, okay? Now, what I needed was an x, right? What I had was this, right? Does that make sense so far? So the way I'm gonna rewrite that, I had the 1/2 because the, divide by 2 mess over there, okay? I'm gonna do this. Square root, because my x is equal to square root of this, right? Squared over u squared du. The reason I did that is because x dx is my du, right? So those go together, right? Is that making sense? One of the x's out of the x cubed goes with my du. You see what I'm saying?
Oh,
I had an x cubed,
but now you made an x squared.
because one of them goes with the du from up here, okay?
But now you made an x squared.
And so now I have an x squared left over that's just hanging out, okay? That's what gets put with us, with that, okay? I feel like y'all might maybe still not understand that, but I don't know.
I wouldn't have thought to do that, but it makes sense when you say it.
Okay, so it does make sense that like you can, but you wouldn't have thought. I'm not surprised you wouldn't have thought. Like you shouldn't have been able necessarily to think of that, right?
Where
Like,
does the 1/2 on the outside come from?
because my du, my derivative of u is 2x dx. So I did the whole divide by 2 thing, right? Like that. So that's why I have the 1/2 over here. But what I wanted to make sure everybody understood was where I changed the x cubed that was in the denominator into this, right?
Yeah, that's.
Yeah, and that this part of it went with the du. But then I still had this little hanging out x squared here. So that's why I subbed in that for that. All right, let's look at another one. I don't think the next one's that bad, but we'll see. Y'all think. y'all have a u du yet?
Well, you can't separate cosine and x, and how'd that work?
Well, I would say consider looking at it like this. Hang on, I gotta rewrite it. Because if it's like that, what's your u? Cosine. And what's your du?
Negative sign.
Negative side. There you go. Okay. Alright. Last one in the slides.
Oh, wow.
Wait, what was the answer?
It was negative integral of 1 over u cubed.
Are we just getting?
Well,
We know you.
figured it out.
This one looks worse than it is. I think you're gonna find, once you realize what the du is, that this one's easier than it seems like it would be.
He's got one plus x and negative second. But what is the oh, it's the root of the it's like the derivative of this one.
That's so
Yeah, but
helpful.
like, what'd you get?
I got negative 2 over x. I think.
I couldn't even
Wait,
solve the regular
Wait,
one.
this is subtract 1 or add 1? I think you're supposed to subtract x cubed at the bottom.
Miss Peters, I got the part earlier. You got me.
Oh.
You got you. I don't even know where I'm going anymore.
What do you mean?
So nice.
These are hard.
Oh no, I know that part. That's
Oh,
not.
okay.
Trust me, that's the part I
That's
didn't
not-
understand.
that's not very confusing.
That's the part that makes
Yeah,
sense
that's
to
not
you.
the confusing part at all. I understood that it was hard.
I'm sorry.
Oh, okay, yeah, it really is that important. It's not that hard. Okay, so you take the derivative of this, and you get this, and then you put that in both. Add negative 2, and you get negative.
That's what I said.
Do y'all think you have this one? Well, what's you?
1 plus x.
Yeah, and what's the derivative of 1 over x squared? Negative 2x to the negative 3.
Why is the derivative of 1 over x squared?
Because that's x to the negative 2, right? So if I take the derivative of that, it's negative 2 x to the negative 3.
Okay, yeah, okay.
That.
Yeah.
So that's our.
That makes sense.
Yeah, so negative 1/2 is mine. coefficient.
You said that was the last one?
Well, that's the last one in the PowerPoint, in the keynote. We have notes. I mean, like, that's just more practice of this that I want us to practice together. And a little bit separately. Just to get, cause the more you do these, the easier they're gonna be. They'll probably never be what you would consider easy, but they'll be easier. So if we're looking at it this way, do you think you could come up with a U and a DU for this? And a rewrite? Well, just try it.
Is this in the notes?
Yeah. Yeah, sorry, it's page 49. Let's see if we've got a U, DU.
Oh boy.
Maybe it is. Maybe it is. Let's see. Let's see. Is that an L? I can't tell.
Yeah, LNX.
Yes, sorry. And then
I did know that part. I knew the U was LNX.
That's correct.
And then, yeah.
We know we don't have that.
One of them, yeah.
Yeah. Wait, that's it.
That's the rewrite.
That's all you said.
Yeah.
So.
Do what?
This is not your right.
Oh. Okay, so, so U to the -1 is, so 1 over U has a special antiderivative because if you added 1 to the exponent, it would be 0 divided by 0, right? So your ln of U is part of X is part of it. So I'll do that in a second.
After that little comment,
Okay.
it's 10.
So antiderivative of 1 over U. What derivative equals 1 over U? The derivative of what equals is ln, right? This is one that has a special thing, okay? So when I take the antiderivative of 1 over U, it equals ln of U, okay? Now, I do want to point something out that I haven't really said, but because ln can't be negative, we always make sure when we take the antiderivative that the absolute value bars go around the argument, okay? All right, so, and then you can plug your U back in. So it's the ln of the ln of x. Now, since the ln of x will never be negative, you can go ahead and get rid of the absolute value bars. Or, well, no, don't do that because you might end up with the ln of 0 and you don't want that. Well, anyway.
Miss Peters, can you just
Can we switch this class to AV?
We've already learned everything.
Yeah.
system math tutor? I'm glad she finds it easy. I don't.
Bro, what?
Where did I lose you, by the way? You said Miss Peters, and then you stopped.
When
I
you
was
said
trying
you
to,
were at the
you
rule,
lost
that's
me
why I
once I
lost.
said the absolute value
Oh,
bars.
sorry. Oh, with the absolute value
I
bars.
just wish I knew how to word that.
Is this gonna be on the
Here,
test?
I'll just skip
Yes.
this.
Bro.
There. I'll just skip taking out the absolute value bars. You just leave it like that, okay?
Okay, but you have the absolute value bars there because ln can't be negative.
Correct.
Okay, so then why remove them? Like,
I mean, because
Because if it can't be negative, why would you?
if this can't be negative anyway, cause it's the ln, it can't be negative. I removed them for this. Never mind. I just went back. I just went back and just leave it like that.
That's exactly what I did. That's what I did.
Alright, let's try this one. Now, real quick, I want you to notice something before you get started, because this is gonna be useful. This, what can I factor out of that?
4.
Okay. And if I have a coefficient, I can just move that to the front, right? So I could actually rewrite so far this whole thing like this, which I think will help you solve it. Like that. Okay, so see if you can go from there with your u and your du.
du is no. du should just be 2x plus 6.
Oh.
And so now. What you do? Hold on. Did you make a loop? Okay, you make a loop. You violate the rope. You pull up on the right. Okay, type that out. Let me cook. Let me cook. And it goes all the way up. And you find it so serious, bro. Let me cook.
Strong, you don't wanna break it. Do not. Because then you have to go back to calculus.
Never mind, I'm not good.
2, 14, there's left 3.
The closest I got to having an answer so far is I drew a smiley face earlier, and then I just.
Alright, well let's figure it out. Where do you go with this one?
well, u is x squared plus 6x plus 1.
That's true.
du would be, 2x plus 6?
Yes.
And so,
What do you do after that?
Well, 2x plus 6 simplifies to what?
1 x plus 3.
Yeah, 2 times x plus 3, right? X plus 3 is what I've got, which is good. So you just divide,
by 2?
yeah, like that,
I knew I was cooking.
right?
Mm-hmm.
Oh my god, I knew I was on something.
So do you just always divide, what, this may just be like what worked here, but do you always just divide whenever you set like the du equals, and you're setting it towards the thing? Do you
Yeah.
always just divide it by whatever will give you the number you need?
Uh-huh,
Okay.
yeah, because I need just this, right? I
Right.
have 2 times that. So basically, I want this side of my du dx expression to be whatever's here. See what I mean? And having that extra 2 here is a problem. So I divide both sides by the 2 so that this matches what's in my integral expression. So then you end up with a 2 times u to the negative 2. I'm not gonna finish that one out, okay? Alright, the next one, there's a lot of space for it, but it doesn't take a lot of space. It actually ended up being really better than you would think it would be. So, try that one.
Can you go back to the solution after that?
Oh, sorry.
So I can write it. Okay, I'm good.
Okay. mean, we still need to practice our antiderivatives themselves, but really, for these, I'm just concerned that you can rewrite them. I wanna do one more after this, one more, and then we'll stop.
Can we go to the next one?
I mean, I've got the one at the bottom ready if y'all are ready to see it.
Why, so, when we identified the u, the x, and it was the x squared plus 6x plus 1,
Mhm.
why did, I probably just missed a step, why did we put it to the second power whenever we moved down and you started writing in the red?
Because the u in the
Oh, it's
original
written, never
expression
mind.
was squared.
Never mind, yeah, I didn't see that.
Alright, we got the next one?
Mm-hmm.
What's our u?
1 over x squared.
1 minus 1 over x. Yeah. And so one of the things that might help you is if you're looking, when you're trying to decide what your u and what your du should be, you think about, like, let's pretend for a second that we made this our u, then that would mean that somewhere in my expression, I would need to have some form of 1 over x cubed in my integrand. And I don't have that, right? So then I look at the other option and I say, okay, what if it's this? The derivative of negative 1 over x is 1 over x squared, right? I do have that. So that means that what's under the root has to be my u. Okay, I wanna look at one more, and I know we're almost out of time, but I wanna look at one more. Because okay. Sine and cosine ones always kind of mess us up because they're both derivatives of each other, right? But I want you to think about the fact that one of these is to the 5th power, and one of these is not. So which one has to be your u, sine or cosine? Sine. So u is the sine of 2x, okay? So that means my du has to be what?
Negative cosine of 2.
Close. Because the derivative of sine is just positive cosine, right?
2 cosine.
But technically we have to chain it to find its derivative, so it's 2 cosine of 2x dx, right? So 1/2 du equals cosine of 2x dx, okay? And again, this needs to match this, right? Those two things need to match when it's all said and done. So for the rewrite, we'll have 1/2 u to the 5th du. And that's all we have time for.
Wait, what were you gonna ask?
Huh?
He just whispered, he goes, where'd that 2 come from in front of the cosine?
Chain rule. To find du, you have to do the chain rule on the sine of 2x.